All right, here we go. We'll talk about 4.3. We're going to talk about scientific notation today. We're going to skip the Explore for 4.3 and just dive right into it. So what are we going to do? We're going to be able to tell the difference between scientific standard and engineering notation. Engineering notation, I'm going to kind of show it to you. We're going to talk about it. It's not, scientific notation is the more important of the two, I would say. Okay. It's the one you're used to seeing. So we'll work more with that. All right. So scientific notation, what is it? It looks like this. Now, some of you, if you're using that like a graphing calculator, your scientific notation may look like this. Actually, it would just be some number and then E to the end. All right. Sometimes, a graphing calculator will use that E letter instead of the 10. It means the same thing. All right. These are the exact same thing here. Okay. It says the size of A, the coefficient must be at least 1 but less than 10. It can't be positive or negative. So what that means is I can only have decimals from 1 to 10. I can't have a number greater, really it's got to be greater than 0. Excuse me, greater than 1 but less, holy cow. Greater than 1 but less than 10. All right. So like it says here, greater than or equal to 1 but less than 10. Okay. For number 3, we're going to determine if the number is given in scientific notation. If not, explain why. I may have misspoken that last one. Greater than 1, meaning the absolute value of this number. If you look at this to determine if it's in scientific notation, the absolute value of negative 2.2 is just. So this would be an example of scientific notation. 550, just like this. No, this is not. No. Yep. This is standard. Standard notation are just the integers that we're used to seeing. Okay, that's what it is. 79 times 10 to the negative 4. That's pretty close, but since this is 79, not 7.9, this is a no. I don't know how would we say that. Coefficient. I'm going to type this. Coefficient is too large. All right, coefficient meaning that's 79. If it was 7.9, that would work. All right, but since it's 79, now I have 0.9. Okay. 0.9 is less than 1, so this would be another no. Coefficient. Holy buckets. Is too small this time. Right? You might say it's not in the correct range. You can say that. We'll say it's too small. This is scientific notation. 1 times 10 to the 0. Yes. 1.6. Yes. This in scientific notation. 1.2. The coefficient looks good. The 1.2 looks good. Times 10 to the 2.3. Oh, cannot have 2.3. Oh, the exponent. I need to have whole numbers as my exponent. Whole numbers only. Okay. 2, 3, negative 5, negative 7. All right, negative 3, negative 4. Oh, would you look at that? G. This would be an example of yes. That'd be yes. We got a nice coefficient to an integer exponent. All right, let's go on. So then we talk about how to move the decimal. Okay, if the starting number was 410,000, if the starting number in scientific notation was 4.1 times 10 to the 5th, that means I move my decimal place 5 spaces to the right. Okay, if it's a positive exponent, that goes to the right, that makes it bigger. If it's a negative exponent here, that goes to left to make the number smaller, which makes sense to me logically. If it's positive, something grows bigger. If it's negative, something's growing smaller. That's also kind of like our discussion about exponential growth and decay. Okay, to a certain extent. Okay, It could be more of our discussion about multipliers, but let's keep going. Remember, if it's negative, move to the left. Like now I'm just continuing to go. Like if we talk about the coordinate, the right side is positive, the left side is negative. Okay, that's also how you can think about it. All right, so convert each number in scientific notation to standard notation. So I have 9.62 times 10 to the 6. So I want to move this decimal place to the right or the left. Yes, that's right, to the right, because it's a positive 6. So I move it 6 times. 1, 2, 3. And every time I move it without a number, I'm going to put a 0. 4, 5, 6. Boom. So I have 900, there's 962, and then 4 zeros. So my standard notation is 9,620,000. All right. Let's keep going. Let's try the bottom one here, 9.62 times 10 to the negative 6. So since it's a negative number, my number is going to be smaller. And I'm going to move it to my decimal to the left. So negative 6, I got 1, 2, 3, 4, 5, 6, and there's my new decimal point. So I have 0.1, 2, 3, 4, 5, 9, 6, 2. Now, some people look for the shortcuts. You know, I would honestly, so we don't make a mistake, just count it. Just move it and count it. All right. Then there was a bunch of stuff, that you can read. Exponent is inside of notation is negative. The size of the number is smaller. All right. It's positive. It's larger. Okay. If it's at 0, it's greater than or equal to 1, but less than 10. All right. So we want to convert each number into scientific notation. All right, so now we're going the opposite direction here. We're going the opposite direction. We had scientific notation, and we converted it to standard notation. Now we want to convert it into scientific notation, so we have to move our decimal place. Okay, so I have 5, 2, 5, 7. So my decimal place, my decimal is right here. I'm going to move it to the left. 1, 2, 3. So it's going to be 5.257 times 10 to the positive 3. Now that is kind of confusing that when I move it to the left, when converting to scientific notation, my exponent is positive. It's the opposite. Okay. If I go to the right, it gets larger if I'm in scientific notation. If I move to the left, it's still positive. So here's how I think about it, okay? If I think about this number here, I have 10 to the positive 3. If I move it 3 spots, do I get my original number? That's what I kind of want to ask myself here, okay? If I move it 3 spots and it all of a sudden is a smaller number, then I know that I did something wrong, okay? So that's a very good way to check your work, all right? So I got, 0.5257. All right. Change the scientific notation. So I'm going to move the decimal place 1 to the right. So I got 5.257. And since I started off with a decimal and started off with a decimal, that means my exponent is going to be negative. If I began with a number less than 1, my exponent must become negative. If I started with a big number, my exponent will be positive. That's kind of what that blow to the top of the page is driving home there. All right, so if we look at this in part C, we have 0.5257 times 10 to the 7th. That is very close to scientific notation. All right, but you'll notice here, this number, our coefficient here, this 0.5257 is less than 1. All right, so I need to make it so that I need to move my decimal place so it's between 1 and 10. Okay? I just have to move it one more spot And if I move it one more spot to the right, now this is kind of confusing. Since I moved it one more spot to the right, I subtract 1 from my exponent. So why you subtract? Okay, that's a great question. Well, that means that when I was putting this in scientific notation to begin with, like I was doing this step up here, okay, I overshot it. All right, I tried to I moved it too many decimal places. Moved it to the right. Oh, I didn't actually need 7. I only need 6. Okay? Another way to think about it is like in part B, analogy to part B. Excuse me. As I move to the right 1, it was a -1. I move to the right, it's negative. If I move to the left, my exponent is positive. Okay, so here I was moving to the left here, and my exponent was positive. Here I was moving to the right one, and my exponent was negative. If I move to the right one, I need to subtract 1. A little weird, but we'll practice that a little bit more. All right, that's it. We'll head back to class.